This is not just a home automation board. This is a fully functional industrial PLC if you know the secrets to mapping its IOs. Today, we are taking the Kincony KC868-A8 and running OpenPLC on it to prove that you don't need a $1,000 PLC for your next industrial prototype project. I will show you exactly how to bypass the ESP32 mapping limitations using a custom C++ block, so you can control all 8 relays with standard ladder logic. Let's get to work. The KC868-A8 is built around the ESP32 ROM model. The board can be powered with a 12-volt DC power supply with the positive at the first terminal and the negative next to it. On the first power up of the board, a boot up test sequence is performed on the output relays. The next terminal connection is common to the digital inputs, followed by the 8 digital inputs. These inputs connect to the ESP32 via an autocoupler module and send their states to the ESP32 via the PCF8574 I2C module. This means that the inputs cannot be mapped directly in the OpenPLC editor. You can also connect other devices to the I2C bus, like an I2C LCD using these terminals. The two 5-volt analog inputs next to the digital inputs connect directly to the ESP32. The board also provides 4 digital inputs, each with a direct connection to the ESP32 GPIO via these terminals. K1 to K8 are the relays for digital output, which also connects to the ESP32 via the ULN2003A driver and I2C PCF8574 IO expander. These consecutive NO, common, and NC terminals connect to the relays, whose states are indicated by these LEDs at both sides of the board. For an IoT smart controller, this RF433 MHz receiver and transmitter can make a significant difference, but they could be extra I/O for other purposes. Having this Ethernet port with the LAN 8270A chip makes the board stand out as a Modbus TCP PLC. While there is no specific UART terminal for the Modbus ROTU, the programming USB port with the CH340 chip can be useful. Here is where most people get stuck. Since this board's IOs run through the PCF8574 I2C chip, OpenPLC cannot detect them out of the box. At first, it makes the board feel completely unusable for your industrial project until you know this one trick in OpenPLC. Now let's create a custom function block from here, with A8 output as the name, and C/C++ as the language. Add out0 to out7 as the function block input Boolean variables to the variable table. Then go to the GitHub link in the description. Copy this code and replace this. The code is commented on, so you can see what is going on. Go to the main program in OpenPLC and add a new ROM. Add a contact to the ROM, a timer on delay block, a timer off delay block, and a coil. Negate the contact. Add a blink variable to it. Assign the same blink variable to the coil, and set both timers to 500 milliseconds. Add another ROM. Go to the user-defined POUs in the Library Explorer and drag the custom block we just created into the ROM. Assign the blink variable to all inputs of the custom block. Now go to Device Configuration and select the ESP32 ROM. Ensure that the KC868-A8 board is connected to your computer with the USB cable, and that the CH340 chip driver is already installed. Then refresh, select the correct port, and upload the logic to the ESP32. When the upload is done, you should see all output LED blinking along with the relays. So, what are your thoughts on this board and OpenPLC? Is it just an IoT smart controller for home automation or a PLC for industrial applications? Drop them in the comments below and let me know the features you would like to explore. Hit that like and subscribe button because you don't want to miss the next episode.